Welcome to Khetz Tutorials, and in this video I'll be talking about tree diagrams. So I'm just continuing on the probability series, writing like a 3-year-old, but that is fine. So tree diagrams, they basically represent events which happen consecutively, so one event after the other. So let's say we first of all flip a coin, then after that we do something else. But this is not the structure of the tree. Now, the tree actually has branches to show the possible options that you have. So for flipping a coin, it either lands in heads or tails. So expect to have two branches. And on the branch, you basically have your probability. And if it's a fair coin, then you do expect to have a half over there and a half over there. And depending on the number of branches that you have, or the number of options, let's call that n, you know that the sum of the probabilities has to add up to 1. So you basically add your probabilities as you go down your branches. So the probability over there and the probability over there. So basically the sum of the probabilities of your options should give you 1. So to make sure that that holds, if each option has an equal chance of happening, then the probability associated with it should be 1 over n, where n is the number of options. Right? So in the case of tossing a coin, it has two options, heads or tails. So you have two options, and that would be the probability of each 1 over n, and the n is 2 options. Now, if you have a die, which is the singular for dice, let's say we have one standard one, which basically has 6 sides, then you have 6 options, and each of the options has 1 over n chances of happening, which should be 1 over 6. So that is how you work out the probabilities of each of the branches. If each branch has an equal chance, then this is how you basically do it, 1 divided by the number of options. But you might find that you have a case where you basically took the probabilities of each, then just used whatever probability you're given. So the general structure of the tree is you have n, where n can be anything, options, and on the branch you have the probabilities, and you basically expect to have consecutive events. So let's say, for example, you toss a coin and it has heads or tails. You can start with any one, just be consistent. So let's start with H and T. Then after tossing a coin, you roll a die which has 6 sides, let's say 4 sides, just to basically make this compact. Then you'd have all of the options for that particular event which follows, which is rolling a die. And once again, you'd write your probabilities. For the first event, you basically have 2 options, so that would be the probability associated with each. And for the next event, you have 4 options, and that would be the probability of each of the branches. Now, if you ask for the probability of a head and any of the options on this side, you basically start at your root, we can call this the root, and go all the way to whatever you're looking for. So you're looking for example, let's say we're looking for a head, then 2. So you're basically going to follow from the root, get to H, so we have H, then follow along to 2. And you basically have your answer. Now, along the path, you encounter 2 probabilities, and you're basically going to multiply the probabilities, those two probabilities that you find along the path, to get the probability of head and something. But if you are told to find the probability of just H, then you don't really care about what happens at this point, right? So it basically multiply the probability of H with the probability of everything that is going on over here, so that you basically have all of your options, which are H1, H2, H3, and H4, then add it up. The only requirement is that you should have your H. So if only one value is specified, you have to add all of the probabilities that have it inside. I do hope that makes sense for now, and if it doesn't, then let's just go through an example so that I basically show all of this. So I'll go through two examples and they are related to tree diagrams. So here's the first example. It says in a game, a four-sided die with the numbers 1 to 4 is rolled and a fair coin is tossed. So first of all, we have a die which has 4 sides. Then after that, we basically have a coin. So these events are consecutive or they follow each other. And for the first question, we are asked to draw a tree diagram to represent the above information or the situation. So let's start. We're told that we have a 4-sided die. So we do expect that to have 4 options. So this is the first event that we're going for. So it has option 1, 2, 3, 4. So it can land on any of these. Then we basically toss a coin after each of these. So we aren't sure which one it will land on. So we have to account for all the options. And that is what we're doing by a tree diagram. We can't say that we know that it will land on 1. If we did know, then we just discard everything else and only focus on the top part. Right? So since we don't know, we are basically saying it can land on 1 and it can be heads or tails, and that is why we're writing out all the options that can happen. Then after doing this, you basically have to write the associated probabilities on the branches. And here we have 4 options, and using the 1 over n thing which I talked about, then each of them would basically have a probability of 1 over 4, which is the same as 0.25. So you can write it in fractional form or you can write it as a decimal. And over here you have 2 options. Therefore, your probabilities should be a half throughout. Half or half or half. Then, after finding or after having all of your options, you basically have to write them out. So 1h and 1t, 2h, 2t, 3h, 3t, 4h, 4t. And this is to show that you basically understand that we can actually land on any of these. So you have to write out all the possibilities. You can start from 1, then go to h or to t, and that is covered over there, and so on. So after drawing your tree diagram, after putting your probabilities and all your possibilities, you have to write this down. Now we're basically done with the tree diagram. We set it up. We know that we have 4 options with the first type of event that we had. And after that, we know that we have 2 options when we're flipping the coin. And we now are going to use the diagram to answer the questions that we have. And the first question, which is B, says determine the probability of rolling a 3 and getting a head. So please take note of the end over here. So both of these have to hold. So we are looking for the probability of landing a 3 and getting head when we basically toss the coin, right? So 3h is what we're looking for. Now, where is 3h? So 3h is over there. And remember what I said, as you go along the branch starting from the root, then you basically multiply all of the probabilities that you encounter. So the probability of 3 and a head would be, so let's go along the path. You have 1 over 4. Then on the way to h, and you stop at the value that you're looking for. On the way to h, then you basically have a half on that branch. So 1 over 4, and on the branch you have a half. Multiply that as well. The result is 1 over 8. And 1 over 8 in decimal form is as follows. You can write it as a percentage or you can just leave it like that. And that should be your answer for B. So on the way to your answer, or on the way to what you're actually looking for, you multiply the probabilities on the path. And the next one, which is C, says determine the probability of rolling an even number. So an even number, 2, 4, 6, basically a number which can be divided by 2 evenly or equally, right? We wouldn't want to have the same term in the definition. So determine the probability of rolling an even number. So in this case, we only have 4 options. So which of them are even? So that would be 2 and 4. But now we weren't told anything about the coin. So we have to include everything that has the even numbers because there's no specific instruction about the tossing of the coin. So as long as the output has an even number, we include it in our calculation. And that will result in the following. So we're focusing on 2h, 2t, 4h, and 4t. And to do that, we basically want the probability of an even number, and we're going to add everything that is associated with the even numbers. So starting there, we have 1 over 4 multiplied by a half, and we're going to add this to 1 over 4 multiplied by a half. Then we are done with the 2 part because we've done both of them. Now we're going to go down to a 4, and we have 1 over 4 multiplied by a half added to 1 over 4 multiplied by a half, and that would be your answer. So your answer will result from all of that, and this is 1 over 8, 1 over 8, that would be 2 over 8, and 3 over 8, 4 over 8, 4 over 8 is a half, and your answer is a half. So that is what we have over there. Since nothing was specified about the coin, but they only did mention the condition in terms of the result of the die. So now moving on to the last question in this example, it says determine the probability of rolling a 1 or a head, right? So let's look at that. So let me just erase this to create some space so that we have our diagram in view as we answer the question. Okay, so let's analyze what we're being asked for first. The probability of rolling a 1, so we know that 1 has to be there, and after that, it doesn't say and, so we're not looking for 1h. It doesn't say and, it says or, right? So we have to add the probabilities of everything that has a 1, which would be these ones, and the probability of everything that has an h. So all of these that have an h, we basically have to add those probabilities. So that is what this means. We are either landing a 1 or landing h. So everything that has to do with all of them has to be involved. If it were the probability of 1 and head, we would be only looking at this and you just multiply 1 over 4 and 1 over 2. But now it's 1 or h. So we actually have to include everything that is associated with this stuff. And this or condition, if you remember from Venn diagrams, it basically is the same. If we say the probability of A or B, we basically include everything which is in the circles A or B. And that is what is happening over here as well. So now we have to include everything that has a 1. We have to include everything that has an H. So now if you do that, then we basically should get, so if you do that, you see that everything is the same. So everything's the same on this side and everything's the same on this side. So we can write our answer in compact form. So the probability of 1 or a head, because the multiplication along the path is basically the same. So let's just write our answer in compact form. So let's count the number of multiplications that we're going to do. So that's 1, 2, 3, 4, and 5. So that is 5. That is why I have the 5 over there. And in each of them, you're going to multiply 1 over 4 and a half. So that is how you get the answer, and the result of this should basically be 5 over 8. Right? So 5 over 8 is the answer that you expect, and if you write it in decimal form, it should be 0.625. And if you want to make it longer, or if this doesn't really make sense to you right now, then what we're doing is we want to land either at 1 or ahead. And in each case, if we land at 1, we aren't saying anything about the coin toss. So it can be anything. So once only one value is specified, then you don't really care about everything else that follows. 1h and 1t both have 1 in them. So we include the probabilities of these two. 2h, 3h, 4h, all of these have h in them. So that is why we add all of this in there. This didn't specify that we want a 1 and something else or a head and something else. It only said 1 or a head. That is why we basically added all of these things. So that sums up this example. And in the next video, I just basically do another tree example just so we have enough examples to deal with. I hope this video was of value. I hope you learned something in the video. And if you liked it, just give it a thumbs up. If you haven't subscribed, please subscribe. And I will see you in the next video.